Hello students, we are going to study classification of crystalline solids. Okay, so how many types of crystalline solids are there? Okay, they are basically four types. Okay, molecular solid, ionic solids, covalent or network solids, and metallic solids. Okay, one by one we will be studying that. Coming to the molecular solids, it is made up of what? Molecules. Okay, and it is of three types. Okay, non-polar, polar and H bonded. These all are not so strong forces, they are weak forces. Okay, when we are talking about non-polar molecular solids, okay, it means here between the compound or between the atoms there are what present? No polarity is present. Okay, it's so here which weak forces are present, and these weak forces like what? Dispersion and London forces. This is a type of what? Van der Waals force. Okay, you have studied in class 11th. Okay, so here weak forces are present. The forces between the molecules are weak in nature, so the melting point will be very low, isn't it? Because it can break easily. Okay, now coming to the polar molecular solids, here you can see what? There is dipole-dipole interaction. It means at least these forces are stronger than this London and dispersion forces. Okay, and so here the melting point will be low, not very low, it will be low. Okay, example you can see over here for the polar is what? Hydrogen chloride and sulfur dioxide. Okay, now here coming to H bonded, okay, hydrogen bonded. Here which is bonding is present? Hydrogen bonding is present. Hydrogen bonding is also not a very strong bond, isn't it? You have studied in class 11th, isn't it? So here also melting point will be low. Okay, and hydrogen bonding, best example you can take it of what? Ice, H2O, isn't it? Now coming to ionic solids. Okay, these ionic solids, they are made up of ions. Okay, and they have got what? Coulombic charges. It means here electrostatic force is present, isn't it? And if electrostatic force is present, naturally now the melting point will be high, isn't it? Because here the force is more, isn't it? To break that, more energy is required, so it will have what? High melting point. Okay, example of ionic solids you can take sodium chloride, magnesium oxide, Na plus Cl minus. This is what? Ionic solid. Okay, now coming to covalent or network solids. Okay, these are giant molecules. Actually these are made up of atoms, okay, which has got what? Covalent bonds between them. Okay, so if covalent bonds are present and if these are giant molecules, naturally what will happen? Its melting point will be high, isn't it? Because to break that giant molecules, tremendous amount of energy will be required. So melting points become high, comparatively very high. Okay. Now example can be taken of what? Sulfur dioxide or quaz you can say, isn't it? Even diamond you can take in this in case of what? Covalent or network solids. Graphite also comes in this only. Okay. Now coming to metallic solids, here you can see I have written M plus, this is representing an ion, okay, plus C of delocalized electrons. Okay, so this means what? Here the metal is present, okay, in the ionic form and electrons are delocalized around it. Okay, here you can't see that, but here you will be seeing the delocalization of electrons in case of metallic solids. But here in case of ionic solids, delocalization of electrons are not there. It is perfect Na plus and Cl minus ions. Okay, so now metallic, in this you can see metallic solids, they have got metallic bonding. Okay, and if they have got metallic bonding, so it means this is also not very high melting point it will have. It will have just high melting point, okay, because it will be more than this what? Molecular solids. Okay, now here examples you can see what? copper, silver, iron. Okay, these are all what? Metallic solids. So this is all about what? The types of crystalline solids. So this is all for today. Good day.